In the next section, check it out down here, we're going to have one then more things impacting the outcome of whatever's happening. Sometimes things are going to vary jointly, some things are going to vary directly. One thing you do need to notice is that when it says varies jointly, that means it's going to be multiplied together, okay? Anytime you see it's varying inversely, that means it's going to be divided. And if you have directly, that also means it's going to be multiplied, okay? And you can read over these, take a look at this. If this is what it says, this is what you write over here. How do you always start? You always put K in the top. Let's write that down. Always put K in top. And that's the letter K. It's a very messy K, but always put K. There you go. Always put K in the top. Combined variation. The number of bags of grass needed, that's N, let's circle all our variables, to reseed a yard varies directly. I'm going to highlight some important words. So there's directly with the area A to be seeded, and inversely, there's one of those keywords, with the weight W, there's another variable, the bag seed. And then they give us a sentence that we can actually apply. Okay? And I'm going to write that down. That's the applied sentence, so we're going to have to use that in a little bit. Now, what does this mean? It's saying that in order for you to determine how many bags of grass seed you're going to need, it depends on the size of your yard, and it depends on how much seed comes in a bag. That's what this problem is trying to say. In order to determine how many bags you need, it determines how big your yard is and how much comes in a bag. Let's make our equation. The number of bags of grass needed, N. It varies. Ready? Anytime you hear the word it varies, you write N equals K. It varies directly with the area, but it varies inversely with the weight. And that's how you make that equation. Directly is A. That's why we put it on the top. Inversely was W. That's why we put it on the bottom. K is always on the top. K always goes on the top. Now what we need to do, okay, so that was step 1, to make your equation. Step 2 is to plug stuff in. And find K. Ready? If it takes two bags, if it takes 2 3-pound bags, so 3 is the pound, okay, 3 was the pound, 2 is the number of bags. It takes 2 3-pound bags to seed an area of 3,600 square feet. How many 3-pound bags will it need to do 9,000? Okay, so I have my equation. Now what I need to do is solve for K. Okay. Step 3. I'm going to multiply each side by 3, and I'll get 6 equals K times 3,600. Now I'm going to divide by 3,600. And I will notice that K is 1 over 600 when I divide. That's step 4. Okay? So we solve for K. Step 5 is to make your new equation. Okay? If you're wondering what steps to combine, you combine steps 1 and 4 together. So I write N equals, I keep the A, I keep the W, but K is 1 over 600. There's your new equation. Okay? Next, we answer the question. How many 3-pound bags will be needed to seed 9,000 square feet? So that's the final answer, is we're going to plug in 3 pounds, okay? And we're also going to plug in 9,000 square feet. So I write N equals 1 over 600, because that was K. The area is 9,000. The weight is 3 pounds. That's going to, so we just do N equals, well, that's 9,000 in your numerator. It's 1,800 in your denominator. Divide it out. I'm going to need 5 3-pound bags. Got it 4? We'll do it together when you come back to class. Problem 5 will be the last problem that we do together, and it deals with physics. Gravitational potential energy, PE, okay, there's one of your variables, is a measure of energy. Potential energy varies directly with, notice that important word, directly. Potential energy varies directly with an object's mass. So we have potential energy and mass, and its height. So there's that word "and" is important because it tells us that it matches directly in meters above the ground. Physicists use G to represent the constant of variation, which is itself gravity. Okay, we'll talk about that in a second. And now we have our applied sentence. And that will help us finish our equation. So step 1, we're going to go ahead and write all this out. Our potential energy varies directly with, notice how I'm just following along in this sentence. Potential energy varies directly with an object's mass and its height from the ground. All of that is being multiplied. There was no inverse mentioned. No inverse mentioned, all of its multiplication. Now they wanted us to use the letter G instead of K. Alright, so we'll just write potential energy equals a gravitational pull M times H, mass times height. Now we will plug in our numbers and solve for K. The skateboarder in the photo has a mass of 58 and a potential energy of 2273.6. And what is the gravitational potential energy of a 65 kilometers? So that's going to be what we plug in at the end. Let's look over here for the height. You see how it tells us it is 4 meters high. Now all we need to do is solve for G. Over here I'm going to combine these two. So I get 2273.6 equals 58 times 4, 232G. And then I divide both sides by 232. And I get G equals 9.8. And if you've ever heard that number, it's because it is. It really is. Gravity pulls at 9.8 meters per second per second. Once you get G, I make my new equation. Okay? And I combine that with step 1 and this step down here. I guess it would be a step 4. My new equation is potential energy equals G, which is 9.8. We're replacing G. Write that down. Replace G with 9.8, so you know what you're doing, times M times H. Okay, so I guess we can call that step 3, step 4. I really don't care what step you call it as long as you write it down. There's my new equation. And then the question says we need to plug in a 65 kilogram skateboarder. So I'll say my potential energy equals 9.8 times my mass is 65, and then it says the same height as shown, so times 4 is what they want, the same height. So let's plug it in. 9.8 times 65, or 65 times 4, and I get 2548 joules. And that's a measure of energy, that label. Now, does it make sense that the higher up a heavier person is, the more energy they're going to create? We can do step 5 together, or part 5 together when we come back to class.